Have you ever stopped to just look around? Our world is literally built from shapes. I mean, from the buildings we're in to the signs on the street. But what if I told you that underneath all that complexity, there are a few simple, kind of secret rules that govern every single one? Well, today, we're going to unlock them. So, what in the world does a honeycomb, something made by bees, have in common with a stop sign? I mean, they seem totally unrelated, right? But believe it or not, they share a secret, and that secret is geometry. They're both governed by the exact same elegant principles. Okay, to get these rules, we've got to meet the main players of the game, polygons. On one side, you've got your regular polygons. Think of these as the perfectionists of the shape world. Every side is the same, every angle is the same, super predictable. Then you've got the irregular polygons. These are the wild ones, totally unique, a little bit chaotic, with sides and angles all over the place. Now, this is where things get really cool. It doesn't matter if you're looking at a perfect triangle or some wacky lopsided shape. There's one single rule, a secret code, really, that tells you exactly what all of its inside angles add up to. So how do you find it? Here it is. The secret is this one little formula. It's like a master key that unlocks literally every single polygon. All you do is take the number of sides, we'll just call that n, subtract 2, and then multiply that whole thing by 180. That's it. It's so simple and it works every single time. Let's try it out. How about a hexagon, like in a honeycomb? It's got 6 sides, so our n is 6. Okay, step 2. We take that 6 and subtract 2, which gives us 4. Final step, we multiply that 4 by 180, and boom, 720 degrees. Every single hexagon out there has exactly 720 degrees on the inside. Pretty cool, right? All right, so we've cracked the code for the whole shape. Now let's zoom in a little. Let's forget about the big picture for a second and just focus on the corners, because that's where the real action happens, the angles. First up, let's meet complementary angles. I like to think of these as angle buddies. They're a pair of angles, and when you put them together, they always, and I mean always, add up to a perfect 90 degrees. So check this out. You take a 60-degree angle and its little 30-degree buddy. They're complementary. Slide them together and bam, you get a perfect right angle, just like the corner of a square, exactly 90 degrees. Next up, we have another type of angle buddy, supplementary angles. Now, their goal is a little different. They're not trying to make a corner. They team up to make a perfectly straight line. They always add up to 180 degrees. Take a look at this. You've got this big, wide 163-degree angle. You pair it up with its tiny 17-degree front, and they click together perfectly to form a flat, straight line. 163 plus 17 equals 180, a perfect partnership. So we've got rules for whole shapes, and we've got rules for pairs of angles. But the real magic happens when you see how these simple rules interact with each other. So what happens when we put them all together? Okay, so imagine 2 lines crossing to make an X. This creates something called vertical angles. They're the ones that are directly opposite each other. And the rule here is so simple, they are always equal, like perfect mirror images. Now, those same intersecting lines also create what's called a linear pair. That's just a fancy name for 2 angles that are side by side on a straight line. And hey, that should sound familiar, right? Because they're on a straight line, they are always supplementary. They always add up to 180 degrees. See how it's all starting to connect? All right, puzzle time. Let's put this all to the test. We've got 2 lines crossing, and we only know one single piece of information. Angle 1 is 135 degrees. So using only the rules we just learned, can we find all the others? You bet we can. Let's do it. First up, let's find angle 3. What's its relationship to angle 1? Well, it's directly across from it. That makes them vertical angles. And what's our rule for vertical angles? They're always equal. So if angle 1 is 135 degrees, angle 3 has to be 135 degrees. Easy. 1 down. 2 to go. Okay, now what about angle 2? If you look at its relationship with angle 1, they're right next to each other on a straight line. That means they form a linear pair. And we know that a linear pair always adds up to 180 degrees. So if we take 180 and subtract angle 1's 135, that leaves us with our answer. Angle 2 has to be 45 degrees. All right, last one. Angle 4. We can see it's directly opposite angle 2. And that makes them, you guessed it, vertical angles. And since vertical angles are always equal, Angle 4 must be exactly the same as angle 2. It's also 45 degrees. And just like that, with a few simple rules, we figured out the entire puzzle.
And this right here, this is the whole point. Geometry isn't about memorizing a bunch of boring facts. It's about learning the rules of the game so you can solve puzzles. Once you know them, the world stops being a series of random shapes and becomes a landscape of puzzles that you actually know how to solve.
So you now have the secret code. You know the rules that govern the angles on a street map, the polygons in a building, the structure of a honeycomb. So the only question left is, as you go about your day, what new patterns will you start to see?